Is that people can't actually join the stream. So
All right.
if you have the,
I'm gonna set up the link.
or just shoot me the public link so I can drop it in chat. Hey everybody, we're live. We're gonna do some very fun live coding today, and this is an episode I've been wanting to do for a very, very long time. So I'm very stoked to be here, and I can't wait to write some code and get yelled at by Vaibhav.
Okay, event is updated. I sent it to you as well. We've got some people in the chat, and we should get a few more coming in soon. What kind of hard features are we building today? We will get to this in just a second. But this is, like Dexter said, I think a lot of people underestimate how good vibe coding can be. And a lot of people view it as like, it's great for throwaway code, it's great for stuff that we don't really leverage for a lot of situations. But I think I've been convinced otherwise. I've been convinced that you can use coding agents for really, really hard problems in a maintainable way. So we're going to try that today, live on stream, for a problem that has been aching us for a while in BAML. And obviously, I know the BAML codebase really well, but Dexter has no idea what the BAML codebase is.
Well, we did ship one feature a couple months ago, but you were driving almost all of that, so.
Yeah, but even then, like the fact that Dexter really doesn't know the file system, he doesn't really know how we organize code in there. He doesn't.
I don't know how to run the tests.
You don't know how to run the tests. There's a lot. Do you know how to run the tests?
I mean, Claude knows how to run the tests.
Well, yeah, but the point here is like Dexter really has almost no information about what the real system does over here. So I think a big part of today is going to be to see if we can go from nothing to something from scratch. But for everyone that's tuning in, this is a thing that we do every Tuesday. We call it AI That Works, and the whole point is to show shipping workflows that actually leverage AI in some interesting way, whether it's to build pipelines, talk about the method of building the pipelines, or actually the pipelines themselves, but show real mechanisms for actually leveraging AI. My name is Vaibhav. I work on BAML.
My name is Dex. I work on Code Layer. Oh, sorry. Do you want to finish the one-liner?
No, that's it.
BAML's a great programming language for working with LLMs and AI agents, and it's getting cooler and cooler and weirder and weirder as the days go by. I'm very excited to see what y'all are solving soon. I'm Dex. I work on Human Layer.
And
this is the part where you tell people what.
Oh,
right,
yeah.
Sorry.
I mean, I think actually people are going to get to see it. So rather than talking about it, I think it's going to be a really interesting way to just mechanize how you can work with the coding in an interesting way. If you find this stuff interesting, this is the URL that you can use to sign up for to see our Tuesday events. And if you sign up there, you can subscribe, and we'll send you event invites out every single time. But with that, let's get started.
Cool. I'm going to pull up, I'm going to share my screen.
Why don't we start with just showing the problem up front so then people can get a spec for what we expect to get done today.
Yeah.
So literally right before this call, I messaged Dexter a couple of tickets that we want to get solved. This is a specific ticket, which is in BAML. One of the things that you can do is you can configure any LLM you want with retry policies and all sorts of mechanisms. Now, one thing that a lot of people have been asking for is timeouts. So we want to expose that capability so that users can configure timeouts for themselves. As a part of this work, we started thinking about it. So there's a GitHub issue that we started with. Then we spent some other time thinking about the actual syntax and stuff along the way. But once we realized what the syntax and everything was for timeouts, I kind of just shared all the information with Dex. And Dex, if you want to screen share and just show people what I showed you, let's start with the GitHub issue. And then from there, we can work through to the docs that we have. And for context for everyone watching, like how long have we been working on timeouts? Well, we thought of this GitHub issue. When was it proposed? On March 18th. That was the initial proposition for it, where the idea is that you can say that there's a connection timeout, there's a response timeout, there's a total timeout. And then with fallbacks, where like you're actually falling back to a different model if the first one fails for whatever reason, then you want to have a total timeout for the entire fallback or retry policy kind of attached to itself. And then similarly, if you scroll down further, we realized some problems with like the actual problem is like you want some sort of nesting, so it's not actually like really verbose to write out. But as we did this, I actually assigned this to one of the engineers on our team to go take a stab at. And the engineer did take a stab at this.
Is your engineer Code Arena bot?
No, the engineer is not that. That's like a coding agent that we tried to go solve this problem. The coding agent failed. But do you want to show the markdown stuff that you had?
Yeah. So, just for a little more context here, and just kind of make sure I understand this properly, I'm going to go back to the AI that works repo, and just pull this up in VS Code. I know I said I don't really use VS Code that much anymore, but in this today we're going to look at it. So, because we have lots of good BAML code examples in here. So if you look in BAML source, you will have auto-generated a client's file. And so this is BAML code that talks about different ways that your prompts can talk to LLMs. And so we have this thing called extract date, and you can set a client here, or you can say custom sonnet.
Whatever you want to name it, yeah.
Yeah, so that is mapped to something in here called custom. I guess this got cleaned up a little bit. Oh yeah, there's custom sonnet. So you can have very basic options like just model an API key, and then you can create a higher level abstraction over it that lets you do fallbacks and round robins and retries and things like this. But what's missing in here is timeouts. So if I want to say, hey, we want to try Gemini 2.5, but if it takes too long, we're going to fall back to GPT-4o Mini because it's better to give the user something than nothing. We wanted to be able, it sounds like you wanted to be able to add and then Vaibhav did a thing that I think is really, really interesting, which is actually this reminds me of this technique that Amazon kind of talks about a lot called working backwards, which is basically like write the documentation or write the blog post first before you go write any code, especially for dev tools. So this is like a preview of a doc of like, how do we actually want this to work in reality?
I did not do this. Greg did this. I want to call that out. But our team generally does abide by this philosophy. I think for AI agent coding, it's actually really good.
And then you had sent me one other thing with like the clarified format,
that
right?
was on Slack.
Okay.
Yeah.
I'm gonna.
So we can go through the doc really fast, just so people. Yeah, you may want to share your whole screen.
I'm just gonna grab that client because there are other sensitive things in that Slack thread. Let's see. Okay, cool. We'll go back to sharing the full screen. So one thing that we have...
Let's look at the docs really fast, just so people get caught up on exactly what the objective is that we're going to get to. So if you go read these docs, can you zoom in a little bit, Dexter?
Yeah.
If you go read these docs, this is what we're going to want. We're going to want to add a couple of new keys in here that are like connection timeout MS, which is like time to establish connection, time to first token, because sometimes the stream might not come back yet. Keep on going. Idle timeout, where it's like you want to delay, like the stream is just stalled out at some point, you want to restart in that scenario. Request timeout, which is like just a total request as a whole for end-to-end. And then for composite clients like fallbacks and retry policies and other things, you want to be able to put like a total timeout. The only thing we didn't like about this is now we're adding arbitrary key value pairs inside of here that can be really noisy and hard to detect, and then we might have conflict. So I sent Dex one more update to this, and this documentation file should be updated accordingly. Can you show the HTTP thing that I sent?
Yeah, let me just...
Yeah, which is instead of doing it some other way, all the timeout options should be under HTTP. So all the timeout options should be under an HTTP key. So therefore we don't occupy too much of the key namespace inside of options.
Yeah, you don't want thousands of parameters at the top level here.
Exactly.
Yep. Cool.
So that's the only constraint. I think this is pretty well spec'd out. I feel pretty confident that this is something that we want. Take it away, Dex. What should we do?
Cool. So the first thing I want to do is I want to get this doc as Markdown, because this actually serves documentation is a great specification. We're saying exactly how the user experience should look.
And
so here's our spec. Yeah, go ahead.
I was going to say, I'll let you do your thing really fast.
So first thing I'm going to do is I'm just going to have Claude update the spec to match the new format with the nested key.
And while we do this, one of the things that we're going to talk about is this concept of research plan implement.
Yes.
And while we go code implement this, I want everyone to, we'll get to everyone kind of understanding what this means in a second. But the idea is that one of the first things that we're going to do before we even go do this is first we're going to make sure our spec is actually correct. It's properly specified. And once we've done that, we're going to try and do a little bit of work to go and look through the code base to be like, did we miss something? Because as clarified as this spec is, we really want to make sure it's actually in line with what the code base would expect to some degree and figure out all the parts of the code base that are relevant. Not that need to be changed, just are relevant.
Yeah. And this is all about context engineering, and like we'll give you the high level of this, but if you're watching this and you haven't seen that, like you should go back and watch the episode we did on using context engineering with coding agents. But the basic idea is like the less context you use, the better results you get. And so we're building our workflow around what I call like frequent intentional compaction. And so phase one is like take the spec and create a research document that documents how the code base works today and everything about it that is relevant to solving that problem. And then we use that to build a plan. And all that means is like, instead of having to research, like read all the code and then build a plan, the model already has a baked understanding of how the code base works. So when it gets to planning, it's actually writing the plan in the sweet spot part of the context window, because we always...
You want to let it rip while we talk, because it takes time. And one of the things I want to call out here is this is like, we're literally live coding all of this on the fly. We have no idea if this is going to work. It may work, it may not work. While you folks have questions about this, ask questions along the way, and we'll try and make sure that it's totally up to date with everyone and their understanding of it.
HTTP key. What is this issue number?
I have no idea.
1630?
Yeah.
And I'm just going to commit these so we can see the diff. And we're just going to let Sonnet do this one because it's pretty quick, but it's going through, you can see it's going through the spec and actually making the changes.
Nice.
And I'm going to go back to dark mode because...
Thank you.
Yeah, it's just putting all this stuff. Does this look right to you, Vaibhav?
This does look right. BKT is asking if this is a demo Code Layer. Code Layer, I think, personally, is a great tool to do this, but really it's really a demo of the process. You could do this directly in Cloud Code if you wanted as well. But similar to how I like to use BAML to building a lot of agent stuff because it makes certain things easier, I personally found Code Layer to be a great way to be a nice wrapper around Cloud Code because it's, for me, slightly prettier. And therefore, I navigate the UI a little bit faster.
Wow, okay. This is actually just like a million parallel tool calls all coming through Sonnet. So let me put it on auto approve, and I think we might be done now. Yeah, it looks pretty good. Let's just have a quick look at this. Just skim it. This all looks right.
By the way, this is one thing I've actually learned deeply while working with Dexter on how to do vibe coding. Because to be completely honest, I didn't do a lot of vibe coding. And the reason I don't do vibe coding is because like I'm a pretty damn good engineer and it slows me down in the beginning. But the reason that I was actually getting worse vibe coded is because I wasn't actually, what was it called? I wasn't actually reading every line of the code. So like the thing Dexter did here, where he actually went through and opened the diff to go look at it in a real format, that is important. If you don't read the code, you are going to be screwed. So read the code.
You have to read this stuff. This is not magic. You have to read what it does. The idea is not that like, oh, if you do research, it's the magic prompt that just makes everything better. This is all about giving you, and we do all these slides in other episodes, but it's all about giving you more leverage, right? You still have to do the work, but you're doing it on higher leverage things.
Yeah. So let's go back. Let's see. I think, can you go back to reading and just make sure it all looks correct?
Yep.
And for context, by the way, here, I have more context on the BAML code base, so I will read this stuff and be like, is this good or is this bad? Can you go up? I want to read that complicated one. For fallbacks client. So fallback clients are interesting. They don't actually have, I don't want them to have connect timeout, idle timeout, or any of this stuff.
Okay.
I only want them to have total timeout.
Interesting.
We should probably tell the agent that in the doc.
Yep.
Yeah.
For the fallback one, what was it?
Fallback / round robin. Fallback / round robin / retries.
Just aggregate
total
timeouts.
Just total timeout. Total _, timeout.
Because I think what was the docs basically had, it was this one, right? Because this is actually...
The doc was wrong.
Oh, okay.
Yeah. Yep. Let it rip.
The low level... We'll skip the need for the low-level timeouts to be passed through. Direct clients are the FT, etc.
Yeah.
Cool.
Perfect. Only caveat, Dex, is I think you should be using your voice stuff like you normally do.
Yeah, I will be using voice plenty today. When it's names of variables, I find sometimes the voice one doesn't have a lot of context. And if it's a code base I work a lot in, I'll go into Super Whisper and like update the vocabulary basically. So like it knows how to do Claude code. It knows the names of certain people that I talk about a lot, or even occasionally. But like I had to put your name in there because it keeps putting you in as Vaibhav.
That's funny.
Yeah.
Yeah, and I think one of the other things that I have learned is like if you guys are really vibe coding and you get the hang of this, once you've done this a few more times where you actually can go read something, I highly recommend starting to do tasks in parallel. We won't do that today because doing two tasks in parallel while having to talk to the stream is too hard. It is
It's too much.
really hard.
But and like I'll tell you why I think that works is because your like points that you check in with the agent, or it's not just you have two Claude sessions going and writing code all day and you have to figure out which one is which and all this, but it's like because everything you review is all kind of shaped the same and you know what to expect in between your like prompt sessions and letting it go off, it becomes easier to like mentally model what's happening and you don't have to do as much context switching. Even when you're switching contexts. Does that sound right, Vaibhav? Does that match your experience?
I think so. Honestly, it's just that it seems to work, and I have no real context about why. But it mostly works, and it's like it feels good, I guess.
Vibes are a big part of this. The best engineers I know, like they don't use evals. They just know what works better because they spend 70 hours a week talking to Claude.
Okay, so what have we done?
Okay, so we have our low level stuff here. Yeah, so here's the note that got added. Total timeout present upper bound regardless of the fallback chain exhaust. No further clients are attempted. Low level timeouts should be defined on individual clients, not on the fallback client itself.
Yeah. Cool. That looks great.
Cool. Okay. I'm going to kick off the research. We'll start a new context window for this one since we've already used about 30%. That's the other idea. Is like the goal here is you always want to have context, and I'm actually gonna grab the new versions of the prompts here. So you don't have to include these in the PR Vaibhav, but I'm gonna drop them in here.
Yeah, go for it.
Here.
Watching someone type feels so archaic now. It's like, oh.
We need to make someone actually contribute a CLI that does this for you.
Really?
Yeah. Oh.
I don't have a folder called agents. You spelled agents wrong.
Yeah, I know. Something in my shell does
I don't
not...
have a folder called agents inside of BAML.
Yeah. Okay, so we'll make that. Something in my shell drops the G key when I paste.
Really?
Yeah. Oh, you're gonna love this. If you're not using the sub agents, this is gonna change your world.
Okay.
All right. I think
I'm down. Just merge it. If this works, you'll get the whole thing merged in.
Amazing. There we go. We're Collison installing some agents into your repo right now. Okay. Research. What is the number? 1630. There we go. Now we got the good one. Let's read the spec in at spec. I'm actually going to rename this. And research all parts of the code base that are relevant to implementing this feature. It doesn't exist today, but I just want to know everything where timeouts are handled. Make sure you don't get into the details of how to make an implementation plan. Just tell me all parts of the code base, how the testing works, how the integration tests work, any code gen that's used in the repo to make this feature work, and explain it all for me so that the next agent can pick it up and get to work.
Josh has a really good question. Why are we making a new context window? Is that to optimize the code cache? It's actually not about. It's not about that. It's more about like fundamentally. I mean, we talked about this last week when we talked about the entropic models and where they degraded because they used a million token window and million context model instead of the shorter context model. These systems generally work better when you give the least amount of context you need to actually make it slightly better. And part of why we often recommend controlling the full context window is because a really important part of this whole workflow is actually getting the system to work well. So once we get the spec right, all the work that we did ahead of time in the context window to make the spec correct can be deleted, and we can just reseed the whole context window with just the right spec. So the model doesn't have to be confused about the old spec, what we changed, and then the new spec. It just says purely, here's the spec that I'm implementing. And it doesn't need to remember the history of what led us to there.
Yeah, because basically the less of your context you use, the better. And so as soon as, like all of the work to do the writing and building the spec up, so that we were actually upstream of this over here. I'm just going to drop this in to the white.
If you guys want the commands, I'll post them for you guys. Yeah.
So we actually were over here writing the spec. So the spec is part of our initial user message, which is like, hey, go implement that thing.
Yeah. If any of you want the commands, they're in there, posted in the chat, and you're welcome to go and check out the Claude code yourself.
Yep. They're there.
While
We've
this
linked them and
while this
documented
is
them
running,
before. Yeah. I actually, and if you all saw, I actually canceled the old one and because it was on Sonnet. And for the research, I really tend to think that if you're not using Opus, you're not going to get good results. Sonnet is fast and it writes damn good code, but when you want to reason over a large, complex code base, you should almost always be using Opus. It's worth the money.
I would say even differently, it's more expensive for you to have to stop and then start again if you get the wrong result. So it's better to pay a tax, the more expensive tax, to get it right the first time around. Because a large part of vibe coding is actually feeling good about the process. And if you just feel bad about the process, you're not going to see it through. So I highly, highly recommend just using the better model, at least in the beginning, until you build confidence about what is working or not. Also, Dexter, we're seeing your forehead, just so you know.
You see my face now? Sorry. It's I have a new AV setup today, and the laptop blocks just the very bottom of my screen. So when I need to see something at the bottom, I move it. But
Yamada asked a really good question. Is it possible to make the spec and code connect? What if the code changes? So the whole point of this workflow, Yamada, is actually not to make the spec and code directly connected. What we're really doing is really imagine when you're working with a colleague and you're working together and like pair programming. It doesn't need to stay connected forever. You just need to be correct about whatever you're implementing right now so your colleague can go write something. And that is really, that's really what we're doing here.
Yeah, and this is also why I am very bullish on like basically like, or I'm kind of like meh on like what I might call like code-based documentation and using agents to update the code base, like using agents to update the documentation for other developers to use. Because I think like one of the problems with AI generated code is if everyone on your team is shipping 1,000 lines of code every couple of days because they're all doing these techniques, the research basically gives you on-demand, up-to-date code-based documentation in 10 minutes or so.
So let's see what and this will be really clear as soon as we start reading the research. And funny enough, you guys will understand a little bit of the BAML code base as the research is done, because then you'll be like, oh, cool, I see where this is relevant. And I'll show you some interesting things that I suspect the research pipeline will pick up if it's done.
Yep. So these are all running. So you can see it's invoking these special subagents that are defined in the they're here public in the human layer repo, which is where I got them from.
I posted the link.
Yeah. So I'm just going to pull one of them up. So we have the research prompt itself, which is, this one. So it's like the research, again, its only job is to document and explain. So it's like analyze the thing, launch these parallel subagents, and then we tell it the document format we want. So we want some front matter at the top. We want the user's question and topic, and then we want detailed findings on how all of the relevant components work with really concise. What makes this so good is that the next model that's picking up in the next fresh context window doesn't have to search and find and learn how all this works. It can just go straight to reading files to figure out what changes need to be made.
Exactly.
And then the agents, sorry, let's look at the agents real quick. So like the codebase locator, its job is to document the codebase, right? And so all its job is to just, here's this file, here's what it does. Here's this file, here's what it does. So just finding things. This is like your super grep. And then the analyzer's job gets instructions like basically like find the entry point to whether it's an API endpoint or a CLI or something, trace the data flow from like wherever X happens all the way down to the database or all the way down to the external service or whatever it is, and understand how things change along. And so we use a mix of these different agents, and like the research prompt uses them de facto, and it just says like, hey, here's the one to use and where. You can also steer Claude to use one of these agents by hand. Okay, cool. We're in the, I'm going to put this on skip permissions also.
We should almost be done. Josh asked a really good question of Manus recommended keeping the wrong stuff in. How do you decide to keep it versus to start a new thread? Well, I think, Josh, this goes back to two elements. This can vary both based on when you build your agent and based on and based on what you do with your coding agent when you're using a coding agent. Like using an agent and building an agent kind of have the same philosophy. And what I would say is like it really depends. So for example, let's say what I'm trying to do is debug. If what I'm trying to do is debug, in that scenario, it's actually really useful to keep the history of it in. But once I have debugged, then I'm moving on to the next flow. So like say, for example, the user asked me to generate some SQL statements and it produced a bad SQL statement. And then I errored it out until I got the right SQL working. Well, in that scenario, it's actually better for me to delete all the old SQL statements and only put the right one in there. Or perhaps put a summary of everything that went wrong so I can show the best, so I can show from the main agent's perspective, all I see is the user asked to do this, and I generate this SQL statement, and I produce the result. On the other hand, during the process of actually getting the error, I probably want to put, you mean result instead of error at the very bottom?
Oh, thank you.
Yeah. On the other end, when I'm not debugging, when I'm actually generating the wrong SQL, I probably do want all the errors in there so it can actually debug itself and get to the right response. And
so this is like your error compaction, right? What some people suggest is if you run 3 tool calls and then when you finally get a good one, the next time you send a prompt to the model, just do user message and the SQL and the success, because this is a lot of noise for the model that isn't like productive to the conversation. And Manus says leave this stuff in because then the model, the next time it goes to write a SQL query, it remembers, oh, that table doesn't exist. So it can learn from what was in the context window versus like basically getting errors again.
Yeah. But what's really interesting here, though, that you could do is, can you go back to that thing? Is it's not as straightforward as what Manus says. What Manus says is leave it in always. I'm going to propose a really quick algorithm that I think all of us can understand, hopefully. I
sent you a link to the whiteboard, by the way, if you want to write it.
That's okay. I'll just I'll just reference it on your screen, which is, imagine what I did was I did this, and next time I got a tool call for a new SQL, I actually injected the errors in only at that time. So if I get a tool call for a new generate SQL or create query plan, then I show all the errors that exist in the past 5 queries. But by default, I don't. So for anything that is not a SQL generation command, I hide all the SQL errors. For anything that is, I show the SQL errors. It doesn't.
If it's calling the SQL generation tool, isn't it already too late to like?
No,
by the time
you control the tool. So the SQL generation tool is going to go ahead and generate SQL.
I guess my point is like if you send this context window in and the model says I want to run XYZ query, like
I guess I was describing the model in some other way where like, yeah, I would just want it to indicate that it wants to generate SQL to me, and then I would just toss in the extra error commands in there.
I see. Okay.
Right? That's one thing I could do. I could also update my base prompt or my like RAG system for whatever I use to describe the SQL tables better based on the type of errors I do in like a post-processing world.
So if you separated out the declaration, I want to run a SQL query, from the actual writing of the query itself, then you can inject the errors in between here.
Exactly. And or you can inject it into the original SQL as well, into the original spot from the previous query.
All right, well, this is about context engineering. It is incredibly off topic, so I'm going to jump over here and read the research doc. Let's have a look.
Can you, you know what you should do? You should open this in Obsidian, and it'll be so much cleaner.
I don't have Obsidian.
Ah, unfortunate.
But I can do this.
Do you want to open the G-Grip version? But you can open this if you want.
Okay, cool. So here's our research question. I think this is fine. So let's read the summary. And Vaibhav, I don't know about BAML, and this is like when you're doing this stuff, you should always have at least one person that's an expert in the code base, because you need to be able to read this and make sure it's right and nothing's missing. So Vaibhav, I'm going to ask you to read this and tell me what's missing or what's wrong.
This looks mostly correct. Yeah, there's a new error. Testing. Okay, go down. That is the right file. We do currently have hard-coded timeouts that need to be plumbed through.
Okay, cool.
Yeah, that's what I was expecting it to find. If it didn't find that, I knew it would have messed up, because I know we have hard-coded timeouts. I don't know where, but I know we have them.
Special AWS client handling.
Yeah, because AWS does some weird stuff with its stuff, and then WASM disables timeout. That is correct.
Okay.
Can you go up? Sorry, I can't read that fast. Publishing. API publishes. Yeah, publishing timeouts. Publishing and tracing timeouts don't matter for this. Ignore them. They should not be configurable.
Okay.
So can you just tell the model that?
Yep. So we're going to start Publishing and tracing timeouts do not matter for this, so you can just ignore them. Don't include that information in the document.
Or more likely, tell it explicitly they don't matter. It's better. We do want it to know that those timeouts exist, but like.
Instead, add a note that the publishing and tracing timeouts don't matter, but omit the kind of detailed documentation about what it is. Yep. So we're gonna launch that one, and then we're gonna keep reading. So this is how you kind of like can keep the model working in the background as you're continuing to review. So this doc will update at some point as Claude makes the changes, but well, let's keep going.
Publishing, parsing, location, property handler. Yep, this is all correct. Time and options, blah, blah, blah. I believe that. Visit client. Yep, that's all correct. Correct. And just for everyone else, what am I reading for when I read this code? I'm actually not reading to look for perfect correctness. I'm looking for approximate fuzzy matching. Because if I was looking for perfect correctness, I would actually jump to that line in the code base and then go read it.
And you can do this if you're really skeptical. One advice I give also is like, you should probably not try to make the research 100% correct because there's diminishing returns.
Exactly. So like I know what I'm looking for is I'm like, this file line is roughly correct. And that's good enough for me.
So yeah, line 45.
Can you go back?
Yep.
Okay, request builder, provider implementation. Yep, that's where I call request. It does the right thing. This is all correct. Go on.
Cool.
Composite client. No timeout at strategy level. Yep, that's a current structure. That is correct. Yes, that is correct. No deadline or timeout. So we will need to go add that in. And it's found almost all of them. It has missed orchestrator/stream.rs. So you probably want to tell it that.
You missed orchestrator/stream.rs. Can you add notes about that one as well?
And this is just like where me knowing the code base knows that if I don't say this, it will get it wrong.
In the, which section is this?
Figure it out. I don't think you have to tell it that. It'll figure it out. Oh, sure, you can say that too.
I haven't read the whole thing yet, so I don't know exactly. Yeah. Okay. Cool. Because there might be, yeah, okay, cool. Error handling infrastructure.
Yeah, that's correct. That is correct.
Okay, I made our change.
Go on.
How the tests work.
I don't actually know if that's how the test works, but I'm going to ignore that for now.
Can you add inline code examples of the test for each client SDK generation?
That is a bad bet, but sure, we can put that.
You don't think so?
Yeah, put it. It's fine.
We'll see how it works. We can always roll it back. Cool. CodeGen pipeline, is this relevant?
No, but it probably is actually because we do have to generate code. I mean, not really. We don't really have to generate code, so maybe not.
Okay.
But
yeah, what's nice about this one is like the timeouts is already implemented. It's just not customizable. So you know that the flow is actually correct. Yeah. Like the flow already works.
Well, kind of. But it's close. It's good enough.
Yeah. It's a lot easier than the cancellation one we did.
Yes.
Okay, and then this is code references. This is just going to repeat a lot of stuff about what was already there.
Yeah. So I just want to go read this, though, just so it knows roughly what it's doing.
So here's your test simulation.
Nice. Okay. Can I read the test?
Yeah. Let's go back up.
Show me the Python one first before I read anything else.
Yeah.
A board controller with timeout MS.
So this is just the test for the cancellation stuff.
Yes. So it did. I mean, you're researching, so it's not writing new code, probably.
Yeah. But this is probably actually not relevant. I was more looking for like what unit tests are we going to have to add to test these new fields.
Yeah, you probably should have phrased it that way.
Yeah. That's actually wrong. Can you remove those examples? I'm more looking for what unit tests would we have to add to test the new fields that we want to add here. So can you give me just one example of how and where there is a test to test the actual like BAML syntax, and just one like tight example and where it lives. It's just gonna be helpful for the planning because we're gonna want the planning agent to. Oops. Let's grab this. Sometimes Super Whisper doesn't paste it in, because we're gonna ask the planning agent to build a test for us. So
exactly. So it'll go write some stuff out. That is correct though. Where it does this, it's really all in the property handler. There's nothing else that has to be modified.
Okay.
Yes, Matt said something great, which is you should be using voice to prompt. For coding tasks, if you're not using voice, you're just slowing yourself down. Typing, the reason, and I'll give people an intuition about why this is true, because it took me a little bit to come to the dark side, which is that when you're typing, you almost want to think before you type, and we're almost all instinctively trained to do that. If you make a typo, you're going to press backspace and go write that out. When you're speaking, you're going to speak a lot more freely, and you're just going to inject more information in there, which means that the model will have better context. And the number of tokens you inject, even if you're speaking very, very verbosely, is trivial compared to the amount of context that you will never get in there if you type. So just like speak.
Yep, amazing. Cool. So yeah, it's updated our unit test example with just this. So this is integration test for client timeout config.
It got the spec wrong. Why doesn't it have HTTP in terms of the first one?
Yeah. Interesting.
Yeah, I think it thinks it's optional.
Why doesn't the first one have the HTTP nesting? That's incorrect. You need to reread the spec and then update the unit test. We're also getting a little high on. I try to keep the context under 40%. That's when you get 40 to 50 range. If it's easy and we're almost there, I will usually keep it. But you always want to be pretty aggressive about the context. But I think I'm ready to start doing the plan for this one.
Almost. Trust me that we should just make sure that it's actually good.
Yeah.
Because otherwise it's going to be a waste of time.
Yep.
We should add some caveats in here that I think are not obvious. And I think the spec is actually underspecified. Idle timeout is only relevant if called during a stream. Time to first token is only relevant if called during a stream.
Worth noting, idle timeout is only relevant if called during a stream. And time to first token timeout is also only relevant if called during a stream. Can you update the specification with that note, not the research?
And specifically what you want to add in is orchestrator/call.rs does not care about it, and orchestrator/stream.rs does care about it. And this is kind of that nuance of why I know. This is just me knowing the code base. Like time to first token is a feature that is only relevant if you're calling it with stream, like function b.stream.function name instead of b.function name.
And this is why we say is like this is real engineering. Like other people who say like work a lot with coding agents is the idea that like the best engineers have the entire code base downloaded into their brain or whatever you want to call it. Like that is still super valuable. The same way it's valuable if you're navigating in an IDE and writing code by hand.
Yeah. Cool. Let's go read this now from the top down, so then we can like make sure that we actually understood it. And you probably need to refresh, right?
Yep. And we're refreshed.
Okay, perfect. Okay.
So here's our mod.rs, special client handling, note on the tracing timeouts, perfect.
That's just where the data is. It's in property patterns.
Property parsing, perfect. Yep. Parser database, provider for parsing, AI Anthropic, Vertex, composite clients, no timeout, non-streaming.
Can you scroll up? I want to read the composite clients carefully.
Yep.
Yep. Okay, go down. Okay, that's good. I've read that.
This is the interesting part. Yeah.
Would need total timeout implementation only. Correct. Yes, I think that is correct. Line 221. It may not be in stream.rs. That's probably the easiest place to put it, actually. Can we just open that file and look at it?
Yeah.
And this is kind of where it starts to be like really relevant. Because like if I were trying to do this myself, I would have to think really, really hard.
Yeah, and when we say like, hey, we don't edit files in Cursor, you still probably will end up reading quite a bit of code. God, why? Who did this? Why is? Sorry, we need stream.rs.
Down, yeah. And what line number? There
21.
Go down. Okay, I'm good. This looks correct.
You're happy with this? Is where you would want that stuff implemented, right?
This is where I would want this implemented. So I agree.
Yeah. So this really serves not only as like documentation, but also like very subtle steering to where you want your changes implemented.
Yeah. And can you go up really fast?
Yep.
This is where total idle timeout would be and where time to first token. And it's really interesting that this doc captures all that because like now I'm like, okay, cool. I feel confident that whatever thing is going to work on this will have some context that is really, really relevant.
Yep. And just as a fun exercise, I'm going to go kick off the plan now.
Yeah. Yeah, one other 1630.
Yep. Read the spec in spec.md and the research. Actually, I'm going to show you a cool trick. I'm just going to run create plan, because if you run it with no arguments, it will just ask you, what do you want to plan?
But isn't that extra context?
Extra context, but it's also the right trajectory. So the planning prompt actually is like a 3-phase back and forth with the user. And sometimes if you just run create plan and tell it what to do, it kind of, there's a chance that it skips those interactive steps. And so by doing create plan and then this back and forth, hold on, this is a really important concept. By doing create plan and then having it answer me and then I say the next thing, you're setting the trajectory to be a little bit more towards your few shot prompting the model, that it's often like checking back with the user, and that this is a back and forth, not a just go call tools until the thing is solved. I'll show you what this means.
I believe you, but for this personally, I would just run it because I'm just lazy. Like this would feel like a micro optimization for myself, but I might be wrong.
If you work with these prompts a bit, you will agree with me. Where's this thing? You got too many files in your repo. You're breaking my fuzzy finder.
Bruh, I have a big code base.
Yeah. Once I kick this off, we're also going to run clock. We're going to do this. Let's work back and forth to outline the phases. Start with your open questions for me, and then give me a phase outline before writing the plan. We're just going to give it as much extra steering as possible to try to get...
For this problem, given how detailed the research was, I would have actually just let it rip.
You can. But I'm also like want to kind of show more generally, right? We're not just solving the problem. But like, that's fair. So the research prompt is actually going to go do some of its... The plan prompt is going to go do some of its own research. Say what?
You want to auto-approve everything?
Oh, yeah. I'm also going to kick off a clock, which is count lines of code. Just for audience context on how much code is in this code base.
That's I don't know, man.
You don't want to see it? Let's see. Script 200,000, Rust 200,000, Go 130,000. This is more than last time, dude. This is crazy.
Yeah.
I know a lot of this is generated, though.
Can you ignore integ tests when you run this? Just ignore the integ test folder. Or go into, if there's a way to ignore. Ignore BAML client, basically. BAML _client. Yeah. Just enter, if it finds that. It's like BAML client anywhere in the path. Oh,
we'll do this later.
Oh, you need to use... Do you not use warp?
No, I don't use warp. I use Claude.
Oh. Interesting. Ignoring... Also, star. Oh yeah, maybe that'll work. That'll probably do something. Interesting. I just use warp and I found it to be pretty good for this stuff.
Warp's pretty good if you want to just do it on the CLI. I just do everything in here now. So this thing is researching, again, like, even though the research is pretty succinct, the planning code is designed to do a little bit of research up front as well. This is also so that if your problem is really simple, you can go straight to planning and you don't have to do the full research, especially if you have a smaller code base. You can just do the plan and get better results.
What do we get in clock while it's running?
Let's see.
Let's see what we got. There we go. That looks more appropriate.
Okay. Yeah, now it's all Rust. And do you have decode in there? What is that?
I don't know what the decode. It's reading something as decode. It's probably just like some config files we have.
I mean, clock is an old janky tool, so
yeah, this looks about right. Okay, cool.
Okay, cool. So open questions. Timeout interaction hierarchy. When multiple timeout mechanisms are active, user configured, abort signal, retry policy, what's the priority order?
Wait.
Should an abort signal immediately cancel regardless
Yes.
of timeout settings?
Yes. Abort should immediately cancel.
Should retry attempts each get a fresh timeout duration?
Yes.
Attempts should each get a fresh timeout duration. Cool. It's like as the spec suggests. So it's like it's gonna always try to come up with some open questions. Some of them are just like softballs of like, you want me to do what it said in the spec? Should it trigger between any SSE events, including keep alive pings, or is it only chunks?
Only chunks.
Only chunks. Keep alives do not reset the timer. Okay. Question 3. HTTP block structure. Yes. enforce the structure. Not allowed at the top level. Composite clients should only accept total timeout.
Dude, you gotta switch to Whisper Flow. It's a lot more accurate.
I just downloaded the biggest model on Super Whisper to test with it, but default timeout values. I'm also gonna have to go get a charger in a sec. Should we maintain the current hard-coded defaults, 10-second connect, 30-second read, as fallbacks when no configuration provider? Yes, keep the defaults. Yeah. 5, error information granularity. Yeah, how do you want to display errors to the user?
That was underspecified. Tracked elapsed time. Just BAML timeout error with no data for now. Oh, yeah. It should be a subset of BAML client error. It should be a child of BAML client error. Subclass is a
WASM environment.
Silent degrade if unsupported.
Okay. And then let's look at the phases. So phase 1, and when we're designing phases, what I really like to do is really focus on what is the incrementally testable thing. I don't know if that's actually going to be relevant since you have such good unit integration test coverage, but if you're building like a full stack application, I kind of like, if I'm not going to actually be able to look at it and verify it until the end of phase 3, I'll just have it combine all 3 of those into one phase. There's some art and science to this, but what do you think about this?
Excuse me. Let me take a look and think about this more. I think this is, yeah, that's probably a good phase 1.
So we're skipping the streaming stuff. We're just doing the core client and basic time.
It's really just about like parsing clients is what I would describe that as.
Yeah.
As like parsing stuff.
Yep. Then we add in the BAML timeout error.
Yeah, that makes sense.
Create those errors in the SDKs.
Yeah.
Yep.
Then do this. I would probably move phase 4 right with phase 1 personally.
Okay. 4 phases. Let's do phase 4 right after phase
right as a part of phase 1.
Phase 1.
Yeah, because it's the same parsing. You can even tell that since it's the same parsing logic.
Since it's the same parsing logic file. Okay. Phase 5, testing and documentation. Don't do tests at the end. Add tests as
no, don't do that. Don't do that.
No.
No.
Really?
Leave that for now. The code base is fucked, so that's not how I would tell it. I'll tell you.
What do you want to do? You want to just leave this as like we'll write the test at the
end?
Just
backspace all that so far and just run all the commands you have so far. Give me like 1 second to think about how to tell it that.
Okay, I'm gonna hit this. I'm gonna go grab a charger, and then I'm not gonna hit.
Let it create the plan. Hit enter.
Okay.
Let it create the plan, and then we'll come back to that testing thing in a second.
Yeah, and then we'll read the created plan, and we can iterate from there.
Yeah, exactly. Because I want to read the actual plan, and then I think I'm good. But you should fire it off to let it run the plan. So for context for everyone else, what have we done so far? In about an hour, we've gone through where we had this spec that we wrote that like roughly outlines new syntax that we have. We took that spec, we asked an LLM to go modify it to some more updates. We then told the LLM to go research the BAML codebase to go and understand exactly what the codebase is doing and like what parts are relevant to make that change. And by the end of this hour, we now have even an implementation plan of like, here's how we would go implement this by step. And hopefully in the next 10 to 15 minutes, we'll have the full implementation plan ready to go. And once we have the implementation plan, the rest of this is actually really, really, really fast. Because once a plan is approved, letting a model rip and run is so fast. But the key part is having really, really good documentation there. For example, if you go back and look at this earlier, some of you may have seen that one of the things that we did was we added streaming as an early part of the stream to the actual spec, and because the research did not pick that out as unique. That was an important skill.
That's super high leverage. And this was the whole point of like, a bad line of code is a bad line of code. A bad part of a plan is 100 bad lines of code, and a like misunderstanding of which parts of the system are relevant can tank your entire project.
Exactly. So like because we knew that that information was relevant, we added that in. And that was actually why the model realized that, hey, idle time is only relevant during streaming. And that's what I realized too while doing that. Idle time is only relevant during streaming. And like time to first token is only relevant during streaming. We don't want to like error out in the normal call pattern when you're not streaming for time to first token. So while this is almost done, it's going to go and implement all this stuff. And it's going to write the plan, and then we'll go read the detailed plan. Dexter, while we do this, I want to
what's up?
Go download Obsidian. I want to make you download this.
Yeah, I actually would love to see your Obsidian workflow.
You can't homebrew it. Just download it.
Yes, I can.
Oh, maybe you can.
Bro, you can homebrew anything, man. Okay. Yeah, because you've been talking a lot about how you use this. And actually, one thing I think that is interesting that is like a thing that I find when I work with people on these kind of projects is like, and what works when we're sitting together is like, I think instead of me listening to you and then translating it into feedback, I can just hand you the mic and you can talk at the model. And that's like a thing where it's like when there's two people working, it's really helpful to be able to switch back and forth between who's prompting quickly. And we don't have that today because we're live on a stream and we're not doing a screen share or whatever it is. But like
actually,
being able to
while this is running, can you hold Super Whisper and I'll talk and we'll just see if it pulls it up and listen.
I don't think it can pull my computer audio.
Wait, do you have headphones on? If you take off your headphones, it will listen to me and it'll plug it in.
All right, let's try it.
Let's see if this works virtually. All right. Let's go update.
Okay. So we can do that. I'm going to go back to headphones just for the audio quality, but that's good to know. The point I was making about like Obsidian and stuff is basically this creates one of the workflows that you may want that is helpful for collaborating with your team, right? Because like what makes this workflow really shine is the open folder.
Just open a folder as a vault. Yeah. Plans and put in reader view. So why do I personally like this workflow? Can you zoom in a bit more?
Yep.
Why do I personally like this workflow over using bare markdown files? Well, one is I can switch between reader mode and writer mode. Two, you saw earlier, one of the things that we were doing is we were actually asking the model to go make every edit. Some edits are just easier to make manually and not have to go back and forth between the model. And two, I find reading this to just be prettier. It's just, for me personally, I find this view to be much, much better. Okay.
I like it. So desired end state. This is our like concise spec.
Let's read the first few lines. And I apologize to everyone on the stream that's watching me and Dexter read a bunch of stuff. Sadly, this is just what we have to do.
This is worth it too. Like this is the part you want to be doing and spending time on. I talk to a lot of people who are they get to this and they're like, okay, cool. So like we can use the model to write the plans and we can use the model to write the research. Like what if we had the model write the specs too and we can have the model write a really good spec? And it's like, the plan gives you 10x leverage. The research gives you 100x leverage. Sometimes you just have to learn to be happy with being 100x faster and not try to get to 1,000 because then things become hard in a weird way. And there's sometimes the things that you want to do manually, whether it's reading or manually pruning these specs, that is still worth doing, even though like you've been told that like if you're doing something, AI should be able to do it. There's like a top out where it's like diminishing returns. Does that make sense, Vaibhav? Does that track?
That's right.
Yep.
So let's go on. This looks correct. You're right. As the model will say, you're absolutely correct.
Yeah, we don't say that other thing here on stream.
Okay, that looks correct. Let's go down. Fallback and only support this.
Yep.
What we're not doing, go down.
Be an HTTP block. Not adding detailed metadata to the error objects yet.
Yes. Not enforcing timeout in any WASM environments. Not changing default timeout behavior. 1 second. Not implementing complex timeout inheritance between composite and underlying clients.
Great.
Yes, we're not inheriting timeout. Every client is independent.
Yep.
Implementation approach. Okay, cool.
Cool. Okay, so phase 1. We are going to update the helpers to add the HTTP block.
Can you go up? I want to read this a little bit better. And for context for everyone else, it's like, what are we doing here? Well, we're going to read the code. Notice normally you don't read all the AI generated code. I'm going to read this code because this is relevant. So I will spend time reading this.
And this is like, The idea is that this is higher leverage than actually reading the code the model wrote because it's more of an outline. Like this is actually not going to include every single line of code, but it's going to be the directionally like important parts, and it's going to be line
what's
by
important
line for the
here,
things
we
that
don't
matter.
have good errors here, so we should tell the model that you didn't add good errors for this phase of the plan. Go down. I don't think it did. Let's just read the plan a little bit better.
Yeah, let's finish reading phase 1 and then we'll give it our feedback.
Ignore for now. Okay, that's fine. It has some. Bail is bad. We really want errors.
I think we do want an error actually because I mean that was the other issue we fixed is like they misspelled this and they didn't get an error.
Yeah, exactly. So tell it that we want good errors here.
We want good errors for unrecognized fields in the HTTP block because the user needs feedback to know that they have typed something wrong or unsupported.
Enter. While that runs, we can keep going.
Yep. This is so fun. I love this shit.
Let's go on. Okay, that's perfect.
So this is the config.
Okay, cool.
Unwrap
this part I have no
default.
idea what it does. So to be honest, I'm like, whatever. This is gonna figure.
So we're gonna use the user's config, and then we're gonna map it from milliseconds, and then we're gonna unwrap it or use the default.
We should probably have a way to define infinite in some way. That's underspecified in this doc.
What is infinite? -1?
Yeah.
Whoops. Let's go.
No, let's use 0 for infinite.
If a user puts 0 as the timeout, that should mean infinite timeout and override the default.
What 0 is a timeout?
I upgraded to the Super Ultra model from Super Whisper, and it's not very good.
And I don't know if 0 is the right thing, but like we can use 0 for now. We could also make the user write inf, but that's okay. Let's just do this for now.
Okay, cool. I'm gonna just stash that because it's still working and I don't want to interrupt it. Okay, cool. So now we have.
I believe the errors here are fine.
Okay.
Field.
Unrecognized fields, not as empty. Bail.
Go up. What did it say about providers? Go up. It said something about providers.
Is composite fallback or round robin? Is there any other providers?
It's round dash robin.
Ooh. Okay. In the provider check block, it's round dash robin.
There you go.
And we're almost getting to 40%. So depending on where we're at after this round of feedback, I will probably start a new context window and just be like, hey, we're working on this plan.
Cool. We'll figure out the error checking here. I think the error checking can be much better. So we'll deal with that later. Yep.
Yeah. This is going to change, but okay. Yeah. Cool.
It's cool that the model inferred that 0 is
it's an error.
It's an infinite.
Oh, it did?
Yeah, it did.
0. Oh, this just changed after I put the feedback in.
Oh.
Do you want to have a 10-minute max?
You can just delete that. Just delete that. And this is what I mean. Like, this is like where we don't have to think about this. Maybe, yeah. Yeah, I don't want to put a max on there. Screw it. Who knows how good models get. Maybe we do have 10-minute long HTTP requests that we run.
Do you want to leave this in? This is validator. Like, I think this is the only one.
No, what does the other one do?
It's literally, this is just validating the timeout. So it's like, these mean the same thing. Okay. Cool. All right, let's get to the end of phase 1 and then we can actually, well, let's keep going. Does this look right?
Yeah, this looks about right.
This is just passing it through to the HTTP client.
Makes sense. One thing I don't like about this, can you go up?
Yeah. Yep.
I don't like that this stuff is done over here. I feel like this stuff should actually be done in the constructor. So like the defaults should actually be configured in the parsing. Like for all these timeouts, we have the defaults right there. So we should just like, the default should be as a part of the previous section, not as part of this section. So that way we don't have to reduplicate the defaults like in 5 places.
Okay, so basically the defaults should happen in this section, not the other one.
Yeah.
Yeah. Okay, so now we're at 63%, so I'm going to make a new one.
Oh.
No, we're going to make a new one. Sorry, bud.
Okay.
We're not creating a new plan. We're updating an existing plan. I'll give you the path below. So don't need to kick off any research to start. Just use the guidelines to update the plan. I'm going to give you the path and some feedback below.
You need better fuzzy match.
I know, something's going
on.
on.
Just right-click. You can right-click on that one, the one above. Just right-click on that. Right-click on the file on Obsidian, and I'll give it to you.
Okay. Oh yeah,
Nope.
yeah. Copy path.
Yeah.
Where is
path.
copy? There we go.
You need to put thoughts in front of it.
Yeah.
I would actually let it read the plan and then give it feedback after.
Yeah.
Because then that's going to become like...
In phase 1, part 3, we configured the defaults. I'd like to instead set up the defaults in part 2 where we create the client. Is that right?
Yeah. Or where I parse the client. In part 1, I think, where I parse the client. Yeah. There you go. Cool. Let's keep on going. Can you make it wider again?
Yep.
Yeah,
And
this stuff looks really good. It's actually really simple because it seems like so straightforward in terms of how I would implement it. That's fantastic.
Okay, so 0, no timeout, none, use the default. We're going to move the default up, but...
Yeah.
Okay.
Yeah, so then we'll always have it. And if it says none, and 0 should really be none, I think. But this will do the right thing. 0 and none should behave the same.
Are you sure? Isn't none use the default timeout, but 0 is explicitly set?
No, because it'll be set now in the other code. Yeah, there you go. See, it changed it automatically to reflect that behavior.
Perfect.
Yeah, this is a lot easier to think about.
Cool. Do you want to skim the change it made, or you trust it?
Yeah, I do want to skim the change it made. Ensure. I don't like this happening here. This should happen as a part of HTTP config, like as a part of ensure HTTP config.
This should happen as a part of ensure HTTP config. Oops.
So it actually... What happened? Yeah. So it'll do the defaults there.
Okay, cool.
And once it's done, I hate that you're absolutely right. It's so frustrating to see.
Yeah.
Okay.
It's frustrating to see this early in a context window.
It's fine.
Okay. And then composite client, total timeout.
Make it wider again?
Yep.
Okay, let's keep reading.
Well, it just made a change. Let's go check the change.
What? Why didn't it make the change in the right place? Go up? Okay, so it did do this here. If it's not a composite, it adds some default in there. That's good. That is correct.
It also rolled... I don't know. I edited this in Obsidian. I don't know if it actually saved.
It does save. You just have to hit Command S, but that's fine.
It's going to remove this stuff.
Yeah, you're done.
And since I don't trust it...
you can go confirm. Just like a less than 0.
This is the research. That's why. Okay, good.
Yeah, it does.
Cool. All right.
Yeah,
Command S works.
Yeah.
Okay. This looks good. This looks good.
Wait, can you...
Why is it doing this twice?
That's fine.
Connect timeout, request timeout. Okay, the 2 different timeouts.
Yeah. Composite prime, total timeout. That's fine. Does this work? Can I see this one more time?
Yep.
Yeah, orchestrate. I want to look at how orchestrate works. Total timeout. Okay, yep. Yeah, that's correct.
Board signal's already there. Existing retry logic with fresh timeout per attempt.
Yep, that's correct. Okay.
Looks good. Does this need to be a special error, or is this right?
That probably should be a special error, but I think that's okay because we haven't implemented the error yet.
Yeah. Okay. And then for streaming, we're going to do basically the same thing. So this is the compaction part, right? We're not writing every single line of code, but it's like, okay, we did this, and this is going to be about the same.
Yeah, I think the only difference is we should use Tokyo Select here, but that's a separate problem. I'll deal with that later.
Are you sure you don't want to change that?
Yeah. You should tell it that. You should tell a code layer. Like, we should use... I just use Tokyo Select. It'll know what I want.
Probably should have told it phase 1, but okay.
Figure it out.
Error examples for user feedback.
Yeah, can you make it read-only view again? Yeah. Connect timeout. Yeah, that's good.
Unrecognized fields, supported timeout fields. Not allowed for composite. Composite clients only support. Connect must be non-negative. 0, valid means no timeout. Yeah, these are all our test cases, basically.
Yeah, and you should... I think there's something in the doc that's somehow telling it that there's... Yeah, there you go. You got that right.
The select stuff, this is right?
It looks more correct than before.
Okay, here we go. Okay, cool. Cool.
Okay, that phase looks correct. That is not the right... That is we don't have make files.
Yeah, that's actually... I have a global Claude ND that steers it to make, and I'm going to have to get rid of that. Those are the wrong testing commands at the end of phase 1. What should I tell it to?
Yeah.
I'm also I'm a little bit worried this isn't actually telling it to add unit tests.
There are no unit tests here, but that's okay. Well, I'll talk about testing in a second with BAML.
Okay. Cool.
I would probably say is it's kind of meaty for phase one. It should really just get all the configs right. That's what I would call all of phase one. All of phase one is just configs right. And
so what do you want to take out?
I would just split out phase one to the parsing and actually adding the timeouts as phase two.
Cool. Yeah. This is like a thing in phase design, right? Is you want to, it's how would you build this, right? How much code would you write before you pause to like run something?
Yeah, and the reason, by the way, I say this is because I know that we can add tests at the parsing layer first before we add tests for the rest of it.
And I might honestly just say like everything cargo test passes.
I'll tell you specific tests to run actually after this.
Or the model can do it.
Yeah, I know, but I'll tell you what to run, and then you can just tell it that. It's not actually cargo test. We'll have to. If you edit this here, it's going to edit it again. You're going to get screwed. So you can't multi-hop.
Yep. Okay.
Well, let's keep reading though, because even if it renames the phases, that's fine.
Yep. Okay. Error handling enhancement.
Yep. This is correct.
Python SDK error. TypeScript SDK error. Go SDK error.
Cool.
Looks good.
Well, Go SDK doesn't have errors yet.
Oh, really?
Pretty sure that doesn't exist. I'm like 85% sure that does not exist.
Just want to see what is it doing here.
While we're doing this, and while Dex is running this, feel free to keep firing them off while this is executing, because like we have a lot of downtime while this runs.
Yeah, and this is why actually I think pair programming is really good for this kind of work, because there is a little bit of downtime, and if you're doing it solo, I would just go check Twitter or something, but when you're sitting with another engineer building stuff, you can actually take the downtime to like engage on the problem, think about what's next, talk about some of the things that we haven't figured out yet. Do we have more questions?
Keep on going. I'll let them know what's the questions coming. I'm watching the chat.
Cool, thanks. Okay, so phase one is parsing and validation. This is ensure HTTP config. And then phase two should be, and so yeah,
now what I want to, cargo test is not enough. Now what I'll tell you is I'll actually show you how to add tests. The way that you add tests is you go into our repo, open our repo really fast, just so you know what I'm pointing to in cursor.
Yep.
Open that, and then go to engine / BAML -lib / BAML / test. Yeah, and then do Command B so I can see the sidebar. And then scroll up. It may not be in validation files.
Oh, here we go.
So this is where a new thing in client, open client, and then be like, boom. Be like, hey, add new test to this file. These are all incorrect, but there's a mechanism to run them. Copy path. Yep. And just tell it to add test. For phase one, you can add tests to this file. Yeah. And then the way that you run them is cargo test from within that, no, not to the whole path, just engine BAML lib / BAML.
So yeah, one thing I will say is this is the kind of thing that you're not going to want to tell it manually for every plan. And so this is the kind of thing where you could go update your create plan command to say, to give a guidance around how the tests work for different parts of the code base. We're not going to do that today, but that's like room for improvement.
Specifically what you want to tell the system is this is how you run parser tests. Like this is how you run like parsing tests or like AST validation tests.
Read a few other files in there to get a sense how it works.
Yeah. And also tell it that the comments automatically get updated. The comments automatically get updated. The error comments. If when you run update _ expect = 1, all caps. Cargo test ... Yeah, there you go. So like that's just like a mechanism that we have. Yeah, cool. That's it. Tell that. Now it should be able to go good test. That's why I didn't want to do testing stuff earlier, because I wanted to have some context here. I was like, there's just no way that we'll get this right in that part of the
yeah. Well, you want to kind of read the plan and you know what it already knows, and that gives it enough context to actually go put in the right unit test.
Exactly.
Cool.
And Repo asked a good question. Are we using Obsidian as a knowledge base or just as temp for creating your prompts or context? I personally never save my prompts and my research and plans in my code base permanently. it's like a separate artifact that lives independent of it. And Obsidian is just a really good markdown viewer and reader. So that's what I read.
Yeah. And also, like, a thing we found a lot is, like, we in the past have, like, kept all historical research and plans and given the model access to, like, review them for historical context. And what I'm finding more and more is, like, you almost never want that. And so what you want is you want the model to have access to all of the research and plans and specs for a specific project. And I say project, I mean, like, this issue that we're solving. And then when you move on to another project, all that stuff becomes not by default visible. Unless you ask the model to, like, go search for specific things. We do have a couple files that I call, like, golden research, which are just like, the model should probably always be able to find this stuff because it's like, here's how the tests work. Like, this kind of information could get put into a research file that is always available to the model, but you'd want it to, like, be kind of like hand manicured and really, really, because that's a high leverage thing.
Can I read the plan?
Yeah, let's see what it did.
Okay, cool.
Yep.
Add validation test. Okay, go on. So go down. And so it just shows you error examples, but then actually starts adding validation tests. That's great. That's great. That's great. That's great. And then it will tell you how to go do this. It now tells you invalid tests, what are happening. Cool. That's fine. Like, all these errors and stuff are totally fine.
Cool.
It adds a bunch of tests, and then it should make them pass, and some of them won't pass, so then it'll just, like, run the diff themselves. Cool.
Error messages.
I would actually run phase 1. I would just let it run phase 1.
Cool. And then we'll go back and fix the rest of the plan once we know what's up.
Exactly. So while we're waiting and reading the rest of it, I would let it run on phase 1.
So would you actually run every single one of these commands?
Yes, that is how I would run this. Yes, that is correct.
Make sure this passes. So it does have the same thing.
I would get rid of default. Our defaults are applied for non-composite clients. Yes. Yeah, I would get rid of that.
Yeah, we're just testing the parser stuff.
Yep, there you go. That's all fine. You can leave that there.
It'll probably only run it once.
Yeah, it'll figure it out.
And then we're just going to not do manual verification here, right?
It's fine. Let it be there. I would let it run. And I would just let it run on. And the only reason I would just tell it to only run phase 1. You're gonna start.
Yep, I will. Yeah. But I also put that in there just to oversteer it a little bit.
Create plan.
Cool.
Yeah, implement. Yep, and just let it rip. And now let's go back to reading the plan while this is running. And this is something that I have often done because we've already read phase 1 and we kind of split it into 2 separate plans. I'm okay letting this happen. I am not at all worried about, like, it messing up at this phase. So I will let it go do that, and it'll make some progress, and at some point the code will be done, probably in a couple minutes, to be honest.
Cool. So I'm going to kick off, since this one was getting fairly high, I'm just going to close this one out, and I'm going to use the same prompt. I literally copied the same prompt, which is like create plan, read the file, and then wait for my feedback.
Cool. Let's keep on reading.
Cool. Timeout implementation. So this is the stuff we moved out of phase 1.
Yeah. So it's now actually going to create the client. So this is much better than before.
Yep.
Cool.
And then this is our applying the actual timeout to the sync stuff in each client, and then the composite client total. We have our Tokyo pin, we have our Tokyo select, so I think this all looks right.
Error is out there. I agree with this. I think we should move the error definitions up before this happens. Like, we should expose error will need to be implemented, and it's not done yet. So, like,
in phase 2, let's move the exposed error up and implement it before the
I would just move error definitions before. I would just move error. I would delete that and just tell it to move the phase of defining errors before we actually do the request definition.
So in phase 2, let's just define all the errors first before we go in and do the request definition stuff.
And let's split out the phases. That might interpret it as do it in phase 2.
Do you want to do it instead of phase 2?
I want to do it I want to do it before phase 2. Like, I want phase 2 to move down one more step.
Make that into phase 3, and then add a phase 2 that is just define all the errors first. Cool.
Exactly. And again, it's all about breaking down the problem into smaller and smaller components that are all going to individually compile. Because, like, this is a huge compilation task. So my whole goal is compile as much as possible ahead of time. And one of the benefits, for example, of using Rust is if it compiles, it probably works. Just a Rust thing.
This somehow got our stupid value greater than 10 minutes.
It's because there's a line somewhere in there that says like, look up 10 minutes. I bet you there's a thing in there, in one of the things that says like 10-minute max.
It just rewrote this again. I tried to edit it.
Yeah, but go look up in the other. Go look up in the other one. Go look up in the research.
Didn't read the research though.
It did.
Not in the this is the implementer. This is the thing actually going to like do the code.
What file calls did it make?
I read the plan. My point is like the plan. We edited that plan to remove it, and it got put back in. So this is why I don't. This is why I don't manually edit sometimes, because the model will just keep rewriting it with the new stuff.
I think I have a separate prompt that I use that tells it that sometimes I make edits that you don't have.
I see.
It's fine if it has that. We can just remember that. Like, honestly, a 10-minute max is fine.
No, we're going to fix this.
Oh, it actually completed phase implement? Well, this... no, the implement plan doesn't need it.
I want to update the plan, because every model from here on out is going to see that in the plan, and it's going to be like, oh, that's wrong. I'm going to go fix that too.
Yeah, but then we should be an implement plan. We should do this in create plan. Fire it off. Okay, let's keep on reading. It did.
Hold on. No, because I want to make sure that the actual implementer also has that. Updated the plan for validation to simplify the logic. Read the file again and update the validation. I'm just going to stage that. I'm not going to send it.
Okay, cool. Cool. Let me go read this really fast. Let me read the plan while it's working.
Yep.
I want to read the next phase because this part is done. Phase 1 should be done.
Cool. Error type definition.
Cool. That was correct. Correct. Go up. Nah, you're going too fast. My brain doesn't read that fast. And I do want to read everything else.
Yep.
Yes. BAML timeout error. It comes from a client, so we actually have all the client metadata for free. Yes. Yep. Correct.
You said this doesn't exist yet?
I'm pretty sure. I mean, just go check that file.
Yeah, I don't see it.
Cool. That's what I thought. So Go doesn't have errors. Just like delete.
Should we just skip this?
Just delete it. Delete it, and just say like doesn't have errors.
Yeah.
I mean, you can tell me that if you want.
The Go SDK doesn't have support for errors, so remove step 4 from that phase entirely. We'll just skip that for now.
And same with Ruby.
Same with Ruby.
Technically, we do have errors. I just don't want to deal with it right now. And you should say focus only on Python. Whatever. It's fine. That's good enough. Let's go back and read.
Okay.
This thing is still implementing. It's doing its thing. And a large part of actually using AI models is really about just like moving fast and parallelizing. So that's why we're implementing phase 1 without having to go through all of it. It's just not worth the time.
So now we just have Python and TypeScript, and here's the mapping, and that's the end of the phase. Is this right? Like string contains timeout?
No, we will e.isConnect. I don't know what that e is. Can you go to that file? Just like look up what that file reads like. I have no idea. And again, this is just another benefit of having like the actual file references. Like we can just like read this stuff. Just go back and read. No, it's somewhere down below.
Line in execute request or error handling. So here we look at the status.
No, this won't be in here. This is incorrect. This will only ever be in the... I don't know where the error will come. I mean, maybe. Where's execute request match?
So here's a good example of like...
I have no idea what Rust does here to actually see where it happens. Like,
so this is what I'm going to do. I'm going to show you a cool trick. That shouldn't happen here. Use Codebase pattern finder to see how errors from HTTP clients are handled.
I'm pretty sure it does happen there, by the way. Oh. Anyway, that's fine.
Okay. Close enough. We'll figure it out.
It's somewhere in there. Is the other one done yet?
The implementer?
Why is it running make? It's running make.
It's my global Claude MD. Read the damn plan, you nerd.
Cool. And then I think what should end up happening here is once phase 1 is done, then we should be able to get phase 2 to compile. And once phase 2 compiles, then we can actually go implement it.
Yeah. I'm actually going to stop this because the context's getting quite high.
It should be fine. Trust me. I've run it to like 80% for these kinds of tests, especially during the last part of running tests.
But we also have to update all this logic. All the unit tests are wrong because we updated the plan to remove that timeout max. So like we have to fix that, and then we have to get the test passing. It will matter because it's going to fix it and get all the test passing, and then it's going to have to make a bunch of changes and fix the tests again. Trust me.
Okay.
We're working on the plan. We're only doing phase 1. I did one small update to the plan, so check what's been done, and then update the validation logic, and then just run the automated verification steps from the plan. Don't use make, don't read the make file, just run the cargo test commands as documented.
Interesting. Send it.
I got to give it the plan path.
Did you stop the other one? Oh, you
so
did.
We're parallelizing here, but we're parallelizing between phase 1 and also iterating on phase 2.
Cool. So it's gonna run. I guess it's gonna run stuff. I guess auto approve everything.
Yep.
Okay. Cool. Let me keep reading. I know why this error handling is happening incorrectly. The reason that this is happening is this should actually be done in phase. That should be handled in phase 3 later, not in phase 1. So we don't actually have to use exposed error yet.
We're already in phase 3 here.
No, in the implementation. That's phase 2. Yeah, like the error go down.
Yeah.
Go down a little bit more. Go down a little bit more. Oh, go down. Oh, it's during timeout implementation. Okay.
I think it's decided that there's no extra stuff to do. It's already done.
All right, cool. Let's go down.
You want to look at timeout implementation?
Yes. Cool. That's correct. Don't set a timeout. Okay, that's correct. Don't do any of the WASM stuff. Tell it ignore WASM. In phase 3.
Well, now this is trying to do a bunch of stuff in phase. Which phase is this? In phase 3.
Let's just see what it did.
Yeah.
I'll wait for it. And then I think so. We're what? We're in 11:42. So it's been about an hour and 45 minutes since we've been doing this.
Okay, so this is the actual error detection happening here, where we're like updating the enum. Basically, we're adding timeout to the error code enum. This seems correct because we're gonna like emit this from inside the actual like client handling.
Okay, I'm down for that.
Okay, so okay,
Cool. That makes sense.
Then we use the message. Otherwise, we parse the HTTP error.
Can you go up?
Yep.
I want to read a couple more things.
Yeah.
The timeout error will need to have the client name as well. Which
phase is this? I missed the outline. Can I get an outline?
Oh, you can just get an outline. It's on the right side. It's one of those. It is that one. Click on that, the right side, the icon that you had, the sidebar. Nope. And then at the top, yeah, that one.
Yeah, okay, cool. Oh, that's so much better. Okay, cool. So in phase 3... Sorry, it was the...
Section 4.
Phase 3.4.
Section 5.
Section 5.
Oh, that one. This one.
The create errors. This part needs the client name as well?
It needs the client information as well. Since, so you can tell it, since timeout error extends from client HTTP, client error. Cool. Let's go on.
Yeah, I'm just going to check on this one. Okay, that looks good. It's running the tests. It's making some fixes based on some parsing errors. So this is the other thing that's really important is like the better your test, the more you can give the model an objective measure of whether it's correct or not. A lot of people talk about like LLM as judge or code review agents, and it's like the LLMs are bad at judging things, if you ask me, but they are good at reading errors and fixing them. And this is also why like you don't necessarily always want to obsess over getting the plan perfect. You just need to be good enough to get the LLM into this state where it's structuring the right code, it's putting the right things in the right places, it's using the right libraries and the right implementations. And then if there's syntax errors or the wrong method is used here, or it's not cloned properly, then the model can fix all of that.
Agreed.
Yes?
Yes.
Cool.
Let's keep reading.
We'll let that one keep running. We'll go back to our plan iteration session. Looks like that did it correctly. Let's find that clone.
Yeah.
Client name, client.clone. That looks right?
Yes, that looks correct.
Cool. And then the composite client total timeout.
This part is the part that scares me. So honestly, part of me is like, because I actually don't know how to implement this. So let me just look at this. Go down. Okay, I guess sleep until deadline. That's great. Never completes if no deadline. I mean, this will probably work. I think this will probably work.
This is all existing code pretty much, right?
Yes.
It says, or however client name is accessed. Should we have it go make that correct? Or are you fine to have it fix that during the test cycle?
I think that's actually correct.
Okay, cool.
I'm trying to remember in my code.
Yeah, if you're like, I'm not sure, then we can have it go do a little bit more research on the side and figure that out. But that's like, yeah, for pinpoint research, then you can just steer to the sub-agent, so you don't have to go create a new research document.
Part of me is also thinking that we should actually ignore composite clients for now.
For now, just to simplify the plan.
Just simplify the plan. Like for now, let's just make sure that the actual errors work for like primitive clients.
Okay, so let's move the composite client timeouts implementation
/retry.
Timeout / retry implementation into its own phase after phase 3.
Yes.
Yeah?
Yes. I feel way better about that.
Cool.
Just because I don't know how the stuff is going to work. I want to be able to get errors fully working for like primitive timeouts.
And when you start building, like the other thing is too, is you're going to learn things as you do the implementation plan. And so like the smaller you can make your phases, the more you can be like, cool, we're going to implement phase 1 and get that working. And then we're going to go from there and, how do I say it? Like, you may have learnings that cause you to change the rest of your plan in the earlier phases.
Can we go see the other one, see if it's done?
Yeah, let's take a look.
It is.
It says it's done.
Okay, so here's how I know what to do now. What I know now is I want to go look at the validation files that I created. I'm actually not even going to look at the diff. Let's just look at the validation files.
This is the thing, is like, yeah, if you can read the tests and you know they work, then you don't actually have to read every line of code. This is the really powerful bit.
It's in BAML. It's on BAML runtime. It's in BAML lib. Client. Yeah. So it made some of these. I don't know which ones it made, but it made some. It should have. If it didn't make these, we know we're.
Oh, yeah. Here we go. Here's the new ones.
Okay. Can you disable the syntax highlighter here?
I don't know how to do that.
Okay. Well, I don't know either. That won't do it either. Or just select a different file extension, like text. The LSP is always going to pick it. Okay, well, command, never mind.
Oh, there we go. LSP still serves it. It's good.
Yeah, no. It's fine. It's fine. I'll just ignore it regardless. Yeah, there's one pain point that we have to deal with in our repo, and we have got configurations set up. But let's just go read this. So we have a client, we do this, and then we do this. Cool. It says, what's the error? Unsupported property HTTP. That looks like a bad error.
Yeah, that looks wrong. It didn't actually pull it in.
Yes, unsupported property HTTP. Go on. Let's read the next one. What does that say?
Unrecognized fields in configuration block. Connect time. This is for the typo.
Yes. Can you actually tell it to make a recommendation for what thing to make? I don't like this error. It should recommend a. We always like. Yeah. You should just paste the error.
Yeah.
And just say I prefer. Yeah. And just say I prefer a error that recommends.
Wait. Here it is.
Wait, why did that not work?
It's here. It's just it was wrapped.
Wait, what does it say? First token connect timeout MS? Wait, why does it say connect timeout? That is valid.
There's a timeout. There's a typo here.
What's a typo?
Typo is there's only one N in connect.
Oh, okay. Can you actually tell it to give a recommendation on best match? Yes, and we have some functions to already do that. Can you do me a favor? It's fine.
I'm giving you the gift of taste.
Okay, cool. Go back.
Okay, you want to read some more?
Yep.
That looks good. And again, these examples execute, right? When you run cargo tests, it actually like makes sure these errors match.
This is good. This should be a map. This is fantastic. Error. Oh, what does it say?
Total timeout is not supported in like low level. This is only for composite clients.
Yes. Cool. Unsupported property HTTP. We should.
So some of these didn't work.
Yes. So we should figure out why. Oh, it's because validation for those clients are different. So we should tell it that.
Okay. So the error in this file is incorrect. The validation for the orchestrator clients is different. And so we need to make sure that HTTP is supported in those as well.
It's for fallback. It's just a composite clients. And like this is just like if you have a good testing framework, this is much faster to test because I know for
Yep.
sure that the code is running and parsing everything accordingly.
Yep. Okay. We're getting high in context as well, so I am.
Just
If
let it
this
rip.
takes a while to run the test, I'm going to have to restart it. It's still doing the previous thing, so I don't want to interrupt it.
Cool. So at this point, what we have is we have the parsing working. We have the data plumbed through the right classes probably. I say probably because I haven't actually looked at the code, but I do know that the parsing is working and like we've plumbed through the most important part, which is like user syntax into the data model.
Yep. Can kind of skim through here. Cool. Building programming languages is fun.
Yeah, it's interesting at the very least.
Is it normal for this to have no output?
Yeah.
Because we did a grep. Yeah. Okay.
Yeah.
Cool. Our new error. Yeah, the tests are failing because our new error messages are different, so it's going to run it with update expect. Let's see what the new error messages look like. Yeah, look at that. We got our fuzzy finding working.
Yeah,
This looks better, right?
it's slightly better. There's still better things I would do, but I'm okay with this for now.
Okay. I mean, that's the kind of thing that's probably... We've seen that it's easy to polish that part. Cool.
I would just let the last thing rip, even though
I sent it. Okay. Cool. It's going to go work on that. Here's our plan iteration. So new structure, parse and validate, define error types, implement basic timeouts, implement composite timeouts, implement streaming timeouts, testing and documentation, runtime configuration.
Yes.
Good.
And I actually will probably do streaming phase 5 before phase 4. That's actually the only difference I'd make. And the idea is like I want to get the primitive clients fully working end to end before I touch anything about the composite client. This also makes testing a lot easier.
So that's another guideline. Changing spec. We'll have like guidelines to add to create plan.md. This is the thing you should always be doing when you're working with this and you find a thing like, oh, I always want the model to do things X way. Then you want to move it into your infrastructure, which is your commands and your agents. So number 1 was guidance on cargo test, generating new error messages, validation tests, etc. And then the other one was always implement basic HTTP, then streaming, then composite clients in that order. Yep.
But I personally probably wouldn't put this in Claude MD because this is so specific to this thing.
Yeah. There's somewhere where you might want to write this down or keep it handy. We're also like, you may have like prompt snippets that you store, and that's just a thing whenever you're changing the HTTP client logic. Okay. So yeah, okay. Basic timeout, streaming timeouts, composite client, testing and docs, runtime configuration. I don't know what phase 7 is, but we'll get there. All right, you want to read phase 4 then?
Yes, please.
Cool. Time to first token and idle timeout. Here we go.
Okay, this looks pretty good. Okay, I see. Okay, yep, that looks good.
Literally counting clocks. Clocks are hard. Okay, so if this resolves and we haven't gotten a token, then we go. Otherwise, it's the other one.
Yep.
Cool.
Otherwise, we just get the next token. We just keep it alive.
Yeah, okay, so then we set this. Then we have to keep alive. Cool.
Yep.
Cool. And look, I like how it's staying brief here. Cool. And then in each client, we have to pass in the HTTP config to the stream handler. Okay. Sounds good?
This looks good to me.
Okay. I think we're still on phase 1 over here, but I'm just going to do infinite bypass.
Yeah. And then there is a technical design thing that I need to think about, which is what do we want fallbacks to do on certain types of errors? And I think we want the fallbacks to treat like time to first token errors, like errors that it just like timeout errors are like things that fallbacks consume and don't forward up. You just get told that a timeout happens, so then you just move forward. So I need to think about how composites will play into that, but I think this will just work as is right now.
Sorry, so it's like how do composite clients handle timeouts from children?
Exactly, and it's not just composites, like retry policies as well. Because one thing you could say is we want to error out completely on this, but I think what we're going to do with timeout errors is not what we do with abort. On abort, we want to exit fully.
Yeah.
Timeouts, we don't.
Yeah, I think a timeout. Well, so sometimes a timeout is like I want to guarantee that I actually get a response to the user in some amount of time, but I think in general, yeah, timeouts are retriable if you're dealing with like shoddy upstream infrastructure.
Yeah, exactly. And then this should almost be done.
So let's see, doing the expectations now.
Yeah, it's doing the other one where it's actually running like the HTTP one.
Generated 2 warnings.
Problem with Rust, honestly, is the worst part about Rust is yes, while it compiles, it does work. It is kind of slow to compile.
Not allowed for composite. Unsupported property. Yeah, this one's still wrong. Unsupported property. Yeah, it's still not figuring this out. So we've given it feedback and it hasn't figured it out. And so my take here is we actually need to go update the plan more. Or add like a phase 1B that is like fix this thing before we move on.
Yeah.
You see what I mean? Like the composite clients are still not able to fix this.
Yes.
This is correct. But this one, unsupported property, is still there. It looks like something actually died and it didn't make the updates.
Okay. Well, while this is running, we'll see how this runs.
Yep. Most tests are passing. All validation tests are not passing. Oh, this is valid. Great. Typo and field name. Not allowed for composite. Okay. This is better. This is the right error. This is not failing on HTTP now. So it did fix it.
Exactly.
Okay. Cool. Amazing. I'm going to commit this.
Do it. I think that's good. That's a good thing to commit. So like now we're done. We're phase 1.
Yep. And I will leave all the files and specs and stuff in there. You can go clean them out of the PR if you want to.
Yeah, I will do that. Can you show the phase 1 so people can see what the checkboxes did?
Yeah.
Yep. And so it actually will check. The system will actually automatically check off these stuff for you, so you actually know what you're done.
Yep.
Go ahead.
I was going to say, and the implement plan prompt has a little bit of extra steering in it to basically like make it able to resume. So it's like if it has existing check marks, trust that that's done, pick up from the first unchecked item, and verify previous work only if something seems off.
Yeah, exactly. So if we go back and take a look at this, we can remove manual verification. We're done. Or check it off yourself. And probably want to delete stop here for human input. Yeah. Okay, let's go compile the rest of this. Can we look at the compilation steps and error type definitions?
The verification steps. It's going to try to run this with make again.
Yes, so you should tell it how to do this.
Sorry, I'm just going to do this.
Okay, yeah. I didn't know that you use make so aggressively in your code.
I like make because it's language independent and we use a lot of different languages.
We do too, but it's interesting. I wish there was a way to just not load this, because now your make file is going to be not have all your stuff that you need.
That's fine. I'm going to keep this one in. Yeah, this shouldn't be in my global thing anyways. That's better. Cool. There's your secret alpha for the day, is snippets of my Claude MD.
There you go. Cool.
All right, so we use this commit command that kind of splits things out into logical files. It's fine. I probably could have just told it to just make one commit. But are you ready to jump to phase 2?
I am. So we just let it run phase 2.
Let's do it. We haven't read the later phases, but we'll kick that off, and then we'll go back and read the later phases of the plan. Cool. So, BAML 1630, phase 2. Only doing phase 2. I guess that's fine.
That's probably good.
Let's rip, baby. You got this.
You might also want to tell it something else, which is the way that we run tests. So let me send that to you in Slack, so that way you have that for Python.
Yeah, actually, we should before we start this, we should update the plan to have that. You want to Slack it to me?
Yes. I will give this to you. I'm giving it to you 1 second.
Eldar, for your question about Sonnet 4.5 versus Opus, Sonnet 4.5 writes good code, but when you want to reason over a long, complex code base, you really want to be using Opus most of the time.
All right, I send it to you. This is how we run. Let me tell you how we run. And then just tell it to not run the TypeScript test. It'll just take too long.
Are we also doing cargo test? Yes?
Yes. We don't really... Yeah, probably to just compile check. Like the previous test should still pass.
Yep. Okay, cool. Cool. Yeah. So we'll update that in the plan, and then we have a look. Cargo build, cargo test. Do this, do this, do this. Do you want to do the rough check?
Yeah.
Okay.
That's how you check that everything is compile time working.
Do you want to do the build here or skip all TypeScript?
Just skip all TypeScript. Yeah, exactly.
I assume if we weren't on a stream, you would run the TypeScript tests.
Nah, I'd probably not. It's like if Python compiles and TypeScript doesn't compile, it's really rare. It's probably good enough. I'd run it at the very end. Because again, my most important resource is my time. So like I'm optimizing for my time here. So like I have a pretty good proxy that the test will probably pass, and I know I'm gonna run
the Python's
test
good,
eventually.
then you know the TypeScript's good.
Yeah, and I know I'm gonna run the test eventually. So it's like it's not like I'm not gonna do it.
Cool. Amazing.
No, I run Claude Code directly on my machine, and the reason is like, honestly, even if I'm using Opus, I am still restricted to the directory I'm operating in, so it's okay. If the model does end up doing something really malicious, I think you could just like prevent certain, you could just like blacklist certain commands. So like, for example, I know Dexter did something interesting. He typed Python into your shell, Dexter.
I had to get rid of that.
Okay.
But yeah, I had a...
Dexter had a command where if you typed in Python directly into your shell, it would shim it. It would shim Python to say echo use UV instead to make sure that the model could never do anything wrong. And that helped a lot.
Because there's Python in the Claude default system prompt.
Yeah.
But now if I run Python...
You have to reload source.
I think it's in there.
It's because the first one isn't found. It's not a real thing. You have double slash, so it goes to root.
All right. Well, I'm not going to go messing around with my .files, but yeah. Yes, that's the basic idea. Is you just replace Python. The first thing in your path should be something else.
Yeah. That way, if the model does it, just will not trigger the wrong Python. So I think it's the same for all Claude Code stuff.
Yep. Okay, so this one is ripping.
That said, I have had a friend who actually had Claude Code, or I think Cursor actually, not Claude Code, run rm-rf in a very scary directory, in the home directory, /.
Yeah, you shouldn't do that.
And it did that because it actually made a directory called tilde by accident in the local folder, and then it started running that as a shell command to delete that directory, and that is not good.
Do not want that. Yes, internal monkeypatch.py.
Yeah, we've done some interesting stuff.
Does it look right?
Yeah, I mean, that stuff looks right.
Yeah, okay. Cool. We are at hour 2, and we're getting through it. We should think about what's next.
I think what's going to end up happening is we'll get the timeout implementation, and I think it should work for the connect and request timeout.
Mm-hmm.
Like, as long as timeout can you go back? Let's just make sure timeout request is actually
this phase 3 stuff
is only doing the basic stuff. Yeah.
Yeah. So here's our HTTP client. We've read that a bunch. Here's our request implementation, and then we do that for all the providers. And then we detect timeout errors in the execution.
Yeah, cool. That's correct. We should get rid of the WASM stuff there.
Get rid of the WASM stuff?
Yeah, we don't need it. It'll just work.
Let's remove the WASM stuff from phase 3. Just leave it out.
Yep.
This is crazy.
It's going to distract it.
Yep.
Can you go up really fast? I want to see a couple more things. I want to read this error code. Detecting timeouts. Go down. I want to read this. Request timeout, error code timeout. That's good. Okay.
Yep. Okay. Otherwise, we just do one from the status.
Oh shit. What was the code there before? Can you Command Z this? I might have messed up. Maybe we did one.
We can go see what the diff was.
Oh no, we do want that WASM stuff. I was wrong. Oh, this is undo. That was the original code in there. I thought it added for this spec, but that's actually the original code in there.
Yeah, sometimes it's not 100% clear what it's like. It'll reproduce large blocks of the code. It's not always clear. I think this is the only thing that's added, is this if, let, else.
Yes, exactly.
Cool. And then
Can
the
you scroll up?
is fine.
Yeah, that's fine.
Yep.
Okay, let's scroll down. This looks good. Timeout error code, I guess 408. I don't know what's a timeout error code. Is that 408? HTTP request timeout? I guess so.
I don't think it's an HTTP code. Is it?
I don't know. I want to Google that.
There you go.
Yeah, request timeout.
Okay. I've never seen this code before. It's one of those.
Well, HTTP codes are very fascinating in terms of what they have.
Yeah.
Let's
the
keep
teapot one.
Handle timeout in the orchestrator. Okay, so we get the response. If we get a timeout response, then we expose it as a client as a timeout.
There's a timeout
response.
error.
Perfect. Otherwise, we do that. Otherwise, we do that, which is perfect.
Cool.
Yeah.
Does it look right?
I would add some more tests. I want phase before we do streaming timeouts, like phase 3B, almost should be add add a PyTest inside of integ test / Python. Well, I would do phase 3B. I would make a separate phase, a integ test inside of Python / inside of
It's fine.
Python / test.
Yeah.
To validate the timeout error.
Yeah. Use a pattern finder agent to see how this works.
And then also give it the UV commands that I gave you earlier to actually run how. Yeah, there you go.
Amazing. Great. I can see HTTP config as a default. I'm wondering. Okay, yeah. So we have done some tests now and finding a bunch of issues that we're going to go start running. Wow, 300 lines of errors.
This is the problem with Rust. They'll figure it out.
Yeah. Okay. We're already very high in the context window, so I might actually stop it. There's a command I use called /continue.
I would let it go on for a little bit longer.
Nope, I'm not, because they changed the compaction window. This is going to compact in like the next 2 seconds, so we're going to do a manual compaction. Create a handoff prompt about where we are, and it should start with /implement plan and include a ref to the plan file. Fortunately, we might compact as part of this, which would be frustrating. But let's see if the context goes back down. Yeah, see, it already compacted itself. Fuck. Oh, I hate it. We're still going to do a handoff and start over.
Okay.
So this is the prompt it's going to use. Current status is mostly complete. Needs final testing and verification. We did all the stuff. Yes. Okay. Yes. So we have a CLI to code layer that I use that basically lets you have human in the loop for your compaction, because it's going to run the CLI to launch the next session.
So, it's just going to launch that for you.
Exactly. So you let the model create the prompt, and then it's going to use the CLI to do it. This is kind of a thing I've been playing with recently that I've been enjoying. It's kind of somewhere in between clear and compact, but it's a nice form factor. So yeah, this launched another one, and now we should have, there's a state thing here, but it created this new one.
That's cool.
Yeah, so here's the prompt that the other model generated. We're using implement plan. Here's the plan, and then yeah, we go from there.
Nice.
So, cool. Okay, so phase 2 is rocking. This one we're gonna axe, and this one is looking for Python test patterns. So I think it should have found them. Oh, Opus, come on.
Are you out of Opus?
No, they're API erroring. This is why. Can't have nice things. Let's see.
This is actually why I really like Codex, because it actually does not go down as much.
Let's see. Yeah, okay, it's back. It's just a little spotty. I am hoping that the context from this agent that took 3 minutes searching for patterns is going to be available in our context window. Yeah, okay, cool. It says based on the patterns I found, so I think it did find things. Ooh. That's good. Just going to tee up another one in case we need to make more changes. Oops. Yeah, okay. That's fine. Nope, it's not. I didn't mean to send it. Front ends are hard. This one's still cooking. This one's ready. Okay, so major updates. So phase 3B, integration testing for timeout errors. How's this look?
Okay, that looks correct. That looks correct. 50 millisecond timeout. That looks correct.
A 500 word essay. Cool.
And that should fail. Go down.
That's right. Provider OpenAI. Should this be?
That's fine.
Okay.
Let's read this. Yep, that should read timeout error. Perfect.
Nice.
You're going too fast. Sorry.
Yep.
That one, yes, fails. Yep, accounting for overhead of any kind. Why not? That makes sense. Abort after delay. Abort should still.
Should not be a timeout error. This is abort takes precedence.
Yes. Because when does the timeout error happen? Oh yeah.
This looks like 100 milliseconds.
A board takes precedence. That's amazing. Yeah, that's really good. Go on. Synchronous. Yep. We also time out in synchronous clients. That's perfect. Streaming should also time out. That is perfect. Yep.
And then we haven't implemented this.
Yep, that's correct. Include.
This is the power of the Codebase pattern finder.
Yes.
Is like, if you're like, I need to do this thing and I know it wasn't in the research, you can just steer it, go find the pattern, and then use that.
Yes, that is correct.
Okay. And then updating the BAML config for tests. So this is timeout test clients. This is what gets used by the Python test?
Yes. This part I'll figure out. That part looks about right. Yeah, there you go. It figured it out.
Cool. Sick. All right.
And I think this is kind of the point. Like, if I didn't know that we needed these phases, we could be endlessly spinning for a while. But I'm like, oh, I want the Rust code to compile, then I want the Python test to compile. And
it's the same way you would engineer if you were writing the code yourself.
Exactly.
I think phase 2 is done. What do you want to look at to verify it manually?
Just look at the diff in VS Code. Please don't show me the Git diff here. I want to see what files changed. Show me the tree version.
This? No. How do I show you the tree version? View as tree. Okay, cool. So we got this. We got this.
Okay, yeah, it's just doing some like, oh, you didn't get the commit from last time. Interesting. Okay, that's fine.
Looks like it didn't do all the providers, but maybe OpenAI is like the base for everything.
I think this just mixed it from last time and just fixed some compile bugs that your git commit didn't get. Yeah. Okay, this looks about right.
Patch. Yeah. Here we go. TypeScript errors.
Silent, so you guys don't hear my text notifications all the
time. Okay. Cool. All right. Let's start phase 3.
Cool. And I think the really nice thing that a lot of people underestimate in this workflow is just like how like independent each step is. And like for context, this feature, as you guys can tell, is very nuanced. There's a lot of stages to it, and it would have taken forever to implement this. And by forever, I mean like it probably would have taken an engineer on my team
a couple days.
Yeah, 1 day, maybe 2 days of time, and that would be like a good implement. I would be like very like. I personally would be satisfied if it took me 2 days to go from like nothing to it working end to end. If we can get this thing working with me and Dex spending 3 hours here, this is clearly a win. And this is like while we're live streaming and also like not even trying to do other things and be super optimized here.
I think it was just you and me and there was no stream. We weren't taking questions and trying to like talk through the thought process. We could use the downtime instead of explaining what we're doing. We would use the downtime to go like work a separate feature in parallel. Phase 3 is about implementing the actual timeout functionality. And then timing wise, I have us on till 1. I'm happy to like commit and push what we get. We can either do a part 2 next week, or you can pick this and run with it yourself. I don't know what you want to do.
I think if we get this working end-to-end Python, I'm actually very happy. If this works, this means that like the other reason I broke this out is that I can actually ship this and make it usable by users very early on without putting the whole composite features and everything else in there.
You would ship these new fields even if they didn't work for streaming and composite?
Well,
or I guess it's 2 separate features.
Exactly. So composite I would break down to a separate feature. Exactly. Yeah. But I would actually ship it for individual clients because that's still worth it.
But you'd need language support for every language, and you'd need those fields to work on all 3 of those fields to work in every path so that you could document it.
So I would do phase 3B, phase 4 with the streaming support, and then I'd merge it.
And then you'd ship it.
Yes, that'd be enough.
Cool.
I don't need everything all the way end to end working. I don't need composite features to work.
What is this? Runtime configuration and advanced features. Is this nonsense?
No, this is correct.
Okay, this is like the dynamic client registry stuff.
Yeah, exactly.
Oh, it's very short.
I would do this stuff. It is very fast. It just plugs into our code base.
Okay.
Most of what we have actually works really, really simply with the whole system. It's designed in that way where it should be easy for AI to add these features or humans to add these features, which is why like, most sections you see are very short. We spend a lot of time on architecting our code base. Like I would say if you're vibe coding from scratch, this approach will probably not work as well because your code base has no like concrete architecture. Like for example, you know the place where it picked out the wrong error for the property types where it was recommending messages?
Yeah.
That's actually incorrect, the way it's done. We actually have a different way of doing it that will actually give you recommendations. That's a standard format that we have that says, here are all the options, here's the thing the user typed in, pass in the error. I don't want it to use a new method. I want it to use that original method. I just don't want to side rail the whole conversation to fix that.
Well, we got there eventually anyways.
No, it didn't, because it didn't use the original method. There's a method that we have that you have to use that actually does the formatting for you for that kind of stuff.
Okay, but the actual error messages we got are correct. So you're saying it just rewrote that logic itself somewhere?
It rewrote the logic with a shittier version of that logic.
Interesting.
I have good logic that is actually like way more battle tested for a lot more edge cases.
Okay.
So that's kind of how I would think about it, because it does a whole bunch of stuff around preference and ordering and stuff there.
Yeah.
And I don't want that to be the case.
Okay. But that's the kind of thing there's like, okay, once we got the whole thing plumbed end to end, that's a really easy refactor.
Exactly. It's not even a refactor. It's actually like, I will use AI to solve that problem too, but I just don't want to lose, what I don't want to do here is I don't want to lose a train of thought over the details that I know don't really matter.
So we're at 60 again. I'm starting to get a little, again, context anxious.
Yeah, the problem with our code base, like I said, is massive.
Well, also this plan file is getting quite long, and so it's reading the entire plan file to only, like, a lot of this is like stuff that's already done and working, and it may even be worth compacting the plan file.
I have found that has led to worse results than letting the context window with autocompact, personally.
Okay.
And like what I would really do here is I'd probably do all the request timeout with every single client with sub-agents. That's what I probably would have done.
Oh, have it actually go to the implementation with sub-agents and do the testing with sub-agents.
Yeah, that's probably what I would have suggested. Is like better if you really care about compaction. But like honestly, I probably wouldn't even do compaction here. I would just let it rip.
I'm gonna compact because we got pretty. See it already auto compact.
We got 30 more minutes. I think my goal is by the end of this 30 minutes, it should fully run. I think it's good to give it the other phases because then if it has that, it knows what context it can do. Personally, let's keep running this thing. Yeah, we'll just let this run. Actually, the only reason you can't use sub-agents here is very sad because the sub-agents are sadly, Cargo does a lock on the system. You can't test in parallel. It's actually really annoying. And also when you're updating a code base individually, it's very annoying unless you have like separate packages that you're testing in. But if it's all within the same package, you can't really do it in any more parallel, sadly. And incremental compilation is not a thing that Rust really has in a great way, sadly. Yeah, but I don't know if they'll be able to do it, sadly. Honestly, I actually spend very little time thinking about what model to use, and I just let it rip. And then if I run into problems, then I will deal with it. Well, Sonnet 4.5 is supposed to be good, so I think it's worth it. I actually think people underestimate how important speed is. I think most models can write code pretty well, so like I probably would use Sonnet 4.5 or even the smaller. I actually use the shittier Sonnet models all the time. They're good enough. Your philosophy of use Opus always, like personally I have a pretty good proxy of when to use and when not to, and I get really good results without using Opus. I think you can do way harder problems than that too, personally. Yeah. I don't know, that's just my personal take though. Like I found it to be fine, even for really hard problems. Like super long. Yeah, it is all vibes too. No. I think most prompting, in my honest opinion, most prompting, whether it be at the application layer or using coding agents, is all vibes. And the best thing you can do is build a really, really good vibe checker in your own brain of whether or not it's working or not. And if you can do that, that will likely be better than any system you build, because there's always this joke of like, I spent 4 hours automating a 10-minute task. I think the same thing with prompting for most tasks. You're going to spend weeks setting up an eval system for what was a one-day prompting problem. And the infrastructure is not worth it most of the time. Well, no screen share. Yeah, because there's literally just nothing to do. You just have to wait for it to code. Yeah. So I'll tell you like my take on this. So like I've tried showing my team the prompts, and usually what I find is any workflow that I give to my whole team, engineering is such a diverse medium that you usually don't have one thing that fits all. And like, for example, we all use VS Code. We all use VS Code in totally different ways. We all have terminals. We all use terminals in totally different ways. And the reason VS Code and terminals, I think, work really simply is because like there's one medium that they have, which is like reading and editing files, which is a really, really common pattern. But the actual mechanism that you use to read and edit files varies dramatically between every single engineer I've ever met. So like, or just like, for example, use Vim key bindings. I use regular keyboard key bindings. Like engineering is such a dynamic discipline that there's no one homogeneous way to do things for almost every task. We have workflows, like system workflows, like GitHub pull requests and everything that we do clearly have more systematic ways of doing things usually. But even then, every team has different ways of doing this, and it's not really prescriptive. But it's usually just like, hey, thou shalt code review, thou shalt do certain things, but not really how. The how is very loosely defined. And I think for prompting and everything else, like as hard as I tried to get my engineers to do the same exact thing, it actually turns out that they're better when they're doing the thing that is like kind of like an offshoot off of the golden path that works for them and makes them happy and enjoy the work. So, and then same with prompts. Like I think there are prompts that certain engineers like because their workflow is better. It works with their personal style of workflow better. So that was like, I think, one of the key learnings that I've had, which is like, and if I press one workflow on one on people too much, then they won't really have fun anymore. And part of software is not just like being a machine that spits out code, is actually like enjoying the work. And that's almost like, yeah, it's like coming to the conclusion yourself rather than being told what to do. You made 2 plans. Okay. Let's keep on going on let's see where the implementation's at. Let's see what you get. Yeah, now it literally should just do like a quick compilation step, and then we should write some PyTest. And like, honestly, if all the PyTests pass, I'd be surprised. I'd probably run it manually myself because I don't really trust it. Once it tells me that it passed, then I would just like see if it actually passed. Just as a quick sanity check. You know, I don't want to be a schmuck that just like is like, the AI told me it didn't. Like, while I do kind of believe it, it's like for really serious stuff, even if my engineers say the code works, or any team I've ever worked on, if someone that I'm code reviewing said the code works for really serious stuff, I will go validate it myself. Exactly. Because in the end, I'm still on the hook for the code working. Like regardless of like whether I wrote the code or not. And like this is, and I didn't do it before for the previous test because I trusted that system a lot more than this one. This is like an end-to-end test. I'm like, I don't want to think about it. Let's really make sure that this works. But sadly, we just have to wait. I really wish there was a better thing to do than just wait. No, I don't know that. I need to think about this more. That's why also it's like there's a deeper problem here that I need to think about how to do. Don't update creep plan. I would just, oh yeah, okay. Oh, so you're not going to auto approve. Interesting. Well, yeah, I mean, you told it the wrong thing, so it makes sense. That'll fix them. It's going to run. No, this is going to run. I'm like, it's so close. As soon as the PyTest command runs, trust me, I think it's going to work. That part is fast. It'll just compile. Once this compiles, the Python test should just work. I think it's going to be better than you think. So I'll stick on a little bit longer just until we get the Python test running. If we don't get the Python test running on like within the first 3 to 4 minutes of it executing that space, then we can call it. But I think it will run. I'm very optimistic, actually. I think this workflow has worked for me really, really well. And I think what's cool for everyone here is like, look, I know BAML, Dexter doesn't, like the BAML code base. And really all we're doing here is I'm just reading the plan, he's writing all the code. I haven't touched a single prompt. And like Dexter's basically like paraphrased some of the stuff that I've done, but in reality I haven't done most of it. It's it's fine. So why do you do the continue all the time? Is that actually true? Are you sure it deletes all the prompts and not just like summarizes the last few messages in some interesting way? Okay, yeah, I would just double check. I suspect that they probably do something a little bit more clever than just like summarize everything here. I think that's the one other thing that I've learned about myself. Wait, what does it say about Ruby FI? I mean, I just don't care about compiling Ruby. The auto-compact generates a summary of about 3,500 words. You can ask the new agent, what is the daemon fetched in to write word for word the transcript provided as NV file. Yeah. Then you can see the auto-compact, yeah. I think it's because it's just trying to do compilation stuff. Yeah. Okay, now it's reading the plan. That's good enough, to be honest. That is the core package. If that package passes, then the rest of it will, yeah, exactly. Yes. I'm very excited for this. If this works, it's going to be super exciting. And again, I think what's really fascinating about this whole thing is like, this is so much faster than the old workflow. Like, all this is going to do is literally write the Python intake test and verify that the intake test passed. And like, if this works, that means the whole pipeline worked. And now we have like timeouts, at least for part of the code base. Like for primitive clients, we now have support for connection and idle timeouts, which are huge, like connection request timeouts. Yeah, the built-in timeouts or whatever, but like this part I think is the most fascinating. Is like how well does this work? And if this works, then like it's golden in terms of like outputs. Like this will work fantastically. I don't know if it ran the match-in command. Did it? Can you scroll up and see? It did. Oh, it did not. Go up. You need to run the match-in command. Match-in command. Just say match-in. MATU. Yeah, that one. Just tell it. It'll figure it out. And then you do need OpenAI API key. You do? I think so. So you might probably want to stop screen sharing. Yeah, because that's going to fail for a variety of different reasons. I have not. Yeah, nice. So this will. Yeah, we're actually working on fixing this. So this is much faster because like Pio3 and Matrin are just like too slow. Yeah, exactly. So it'll fix itself. I think we're gonna be done soon. I'm very optimistic. We'll see if it pans out. Yep, exactly. Yeah, the diff. That's correct. Now, yeah, it'll figure it out. This part I feel really confident about. It probably had to read the file and then be like, oh yeah, exactly. You got the better version of it. Yep, now that Python compiles. So we know that the compilation works end-to-end. Yep, I think all things should be in Rust. All dev tools should be built in Rust. I have a strong opinion of that. Well, dev tools. Application code, write in whatever you want. But like we're a developer tool. There we go. That works. Run it yourself. Yeah, I want to go run the test, and I want to go. Oh, I mean, I guess we can just look. I want to run the test with a T thing. Do dash V. Yeah. Oh, it is dash V. Dash VVV. Oh, it responded too fast. Oh, I think so. What's the assertion error that you got? Oh, it didn't. The model just responded poorly. The assert is bad. We should get rid of that assert in that test. Because the model is responding with like a string by just knowing it's a string more than 10 characters. And that we didn't fire an exception. All right, that's it. Like this works. There we have it. Like end-to-end Python asserts definitely work. We're getting time. If we go look at the actual, can you open up the thing for me really fast? The code base so we can show the commits. The Python code. I want to show the Python test file. It's gonna be in test. Yeah, test timeouts. Up. Like we're definitely firing these tests and we're definitely capturing these exceptions. Now it's possible that there's still a bug here, so I would have to go and like read this code in really good detail. But just statistically, based on everything that we have compiled and looking at the diff of everything so far, where the only difference is really the client that we're passing in, I find that hard to believe. So maybe after I validate that it's actually good myself. Cool. So Dex, if you can, take all the thoughts, take all the research, take all of this stuff, and put it as a PR up to the repo. We'll take it from here. Yeah. So this was, like I said, a longer form episode compared to what we normally do. And what we will be doing back in the future is we'll go back to writing more code. But today we wrote a lot of code using AI, and hopefully the lessons that we shared around here are going to be helpful to all of you. With that, we're going to peace out and let Dexter get the stuff up and running. Thank you guys for making all the time and tuning in. Dexter, until next time. See ya.